Hello, this is Mrs. Thompson, your instructor, and today we will be talking about the sum and difference formulas. Objectives are for you to obtain an understanding of the sum and difference formulas for the cosine function, sine function, and tangent function, as well as being able to use these formulas. The sum and difference formulas for the cosine function are as follows. The sum of the cosine of two angles is equal to the cosine of the first angle times the cosine of the second angle minus the sine of the first angle times the sine of the second angle. Of course, the angles are referred to as alpha and beta. The cosine of the difference of two angles, that formula is as follows. The cosine of the difference of two angles is equal to the cosine of the first angle times the cosine of the second angle. Added to that, the product of the sine of the first angle times the sine of the second angle. Looking at some examples. This first example is of the cosine of the sum of two angles. The formula has been placed here again for convenience. So, plugging right into the formula, we are to take the cosine of the first angle, pi by 3, multiply that by the cosine of the second angle, pi by 4, and subtract from that what we get when we take the product, where we multiply the sine of the first angle, pi by 3, times the sine of the second angle, pi by 4. All of these angles are angles that you should know the sine and cosine of, because these are the angles that you were required to learn the sine and cosine of in chapter 5. So, plugging in those values, you can refer back to the PowerPoints from chapter 5 for that unit circle. You have cosine pi by 3 is 1/2. Cosine pi by 4 is square root 2 over 2. Multiplying that, we get the square root of 2 over 4. Bringing down the subtraction sign. Sine of pi by 3 is the square root of 3 over 2. Multiplying that by the sine of pi by 4, which is the square root of 2 over 2. So multiplying straight across, we get the square root of 6. And 2 times 2, of course, is 4. Since we have a common denominator, we only need to write it once with the long fraction bar, producing the final answer of the square root of 2 minus the square root of 3 all over 4. Looking at an additional example, this time you are asked to find the exact value of the expression cosine of 15 degrees. Without using a calculator, please remember that exact values cannot contain round decimals that have been rounded. That is not allowed with exact values. So, without a calculator, that means we have to express 15 degrees using angles that we know the sine and cosine of, such as the 45-degree angle and 30-degree angle. 45 minus 30 is 15, so we can make that substitution. This is a difference. We are finding the cosine, so we substitute directly into the formula for finding the cosine of a difference of two angles. So, cosine of 45 degrees, which is the square root of 2 over 2, times the cosine of 30 degrees, which is the square root of 3 over 2. Copying the addition sign from the formula. The sine of 45 degrees, which is the square root of 2 over 2, times the sine of 30 degrees, which is 1/2. Order operation, multiplication before addition, so multiplying square root of 3 times square root of 2 times square root of 3 is the square root of 6. 2 times 2 is 4. Square root of 2 times 1 is the square root of 2. Again, 2 times 2 is 4. Addition sign is brought down. We have a common denominator of 4, so we only need to write it once. Using the long fraction bar for a final answer of the square root of 6 plus the square root of 2 all over 4. Well, our next example is basically an example of using the sum or difference formula in reverse. This time, we are given a problem that is in the form of the right-hand side of our formula for the cosine of the sum of two angles. As we can see, we have the cosine of two angles, subtract the sine of the same two angles. That form is what is given to us. So, applying the formula in the opposite direction, we know that this is equivalent to the cosine of what we get when we add the two angles, 87 degrees and 93 degrees. If we add those, this time we end up with an angle that we know the cosine of because it's one of the angles that we are responsible for knowing the cosine of and sine of around the unit circle. The cosine, the x value on the unit circle for 180 degrees is -1, making -1 the final answer. As you can see, our sine trig function has similar formulas for a sum and for the difference of two angles. Make sure you also familiarize yourself with these. Here are similar examples for the sine formulas. This time, finding the exact value of the expression, the sine of 7 pi over 12. Well, of course, 7 pi over 12 is not one of the angles that you were required to learn the values of, and you're asked to do this without a calculator. But we do know that 7/12 is equivalent to 3/12 plus 4/12. Using our basic arithmetic, we know that 3/12 simplifies or reduces to 1/4 or pi by 4. Likewise, 4/12 reduces to 1/3 or 1/3 pi. Of course, with these, we have to hold on to the pi symbol. After that, it's simply plugging into the formula for the sum of the sine of two angles and simplifying as usual. Please pause the video as you need to study the provided examples. Here is another example using the sine of the difference of two angles, very similar to what we did with the cosine, but again, feel free to pause the video and review this example as well. We also have formulas for the sum and difference for the tangent function. So formulas for the sum and difference of two angles for the tangent function. These two formulas are very similar to each other, as you can see, the only difference being the signs, the operational signs on the right-hand side. However, they are different from the ones that we have covered thus far for sine and cosine. So, providing an example of one of the tangent formulas. So, example, find the exact value of the expression tangent 7 pi over 12. Well, we just talked about that 7 pi over 12 is equivalent to pi over 3 plus pi over 4. So we have our alpha and beta, our first angle and second angle. We just plug this into the right-hand side of the formula, which tells us to take the tangent of the first angle, pi by 3, add to it the tangent of the second angle, pi by 4, adding those two tangents for the numerator, and then in the denominator, 1 minus coming directly from the formula, the tangent of the first angle times the tangent of the second angle. So, replacing the tangent of pi by 3 with its value, which is the square root of 3, the tangent of pi by 4 with 1. Of course, again, you're always working with angles that you should know the sine and cosine of. Of course, with paper and pencil, a little arithmetic, dividing the sine divided by the cosine of the function gives you the tangent. Copying the 1 and the minus sign, tangent pi by 3 already calculated to be the square root of 3, and the tangent of pi by 4 already calculated to be 1. So finishing up, multiplying by 1 will not change the value. So a final answer of the square root of 3 plus 1 all over 1 minus the square root of 3. The sum and difference formulas can be used to verify an identity. Verifying the given identity, of course, we see the numerator is a difference. So applying the difference formula for cosine, then as in the previous section 6.2, recommended approach, if you have a common denominator, dividing that long fraction that contains addition or subtraction in the numerator into its meaning both pieces, the term in front of the addition sign and behind it, shares that denominator, dividing it into that meaning. Multiplication here, so just showing that a little bit clearer by separating it with a dot. Of course, on the right-hand side of the addition sign, we know anything divided by itself equals 1. And then lastly, we know that the cosine of an angle over the sine of an angle is equal to the cotangent of that angle. Same thing again. So now the left-hand side is the cotangent of alpha times the cotangent of beta plus 1, which is identical to the right-hand side. So yes, this identity has been proven. It is true. In closing, please be aware cofunction identities do exist. These are located in section 6.3 in your textbook and also in the back, inside the back cover of your text.